Morning students, today we are going to solve a question from the topic of genetic and chromosomal mutation in the subject of biology A levels. The statement of the question is the graph below shows the effect of the radiation on two small inbreeding populations of the Drosophila derived from the same parental stock. Here is the graph that is in dotted form. So continuous exposure of the gamma radiation, while in the graph 2 there is control or no exposure. What causes the rise in the graph 2? The right answer is A part, that is spontaneous mutation in a small gene pool. Actually, graph 2 represents the control group, which has no exposure to the external gamma radiations. Despite having the no radiation exposure, the graph shows a gradual rise in the percentage of the lethal mutations over generations, eventually leveling off around 25%. Because there is no external radiation applied to this group, any new mutations must be occurring naturally and randomly, and this is known as spontaneous mutation. B is incorrect because natural selection acts to remove lethal mutations from a population because individuals carrying them die or fail to reproduce. Therefore, natural selection would cause a decrease or stabilization of the lethal mutations, not a rise. Whereas the C part is incorrect, a decrease in the genetic drift. So, in small populations, genetic drift actually increases, not decreases. Genetic drift can cause random fluctuations in allele frequencies, but it does not directly explain a steady, consistent rise across the generations, like spontaneous mutations and inbreeding do here. D part is incorrect because the label for the graph 2 explicitly states control no exposure, while normal baseline background radiations always exist. There is no evidence or reason to assume background radiation is increasing over the course of the experiment. The E part is incorrect because since the control population is not exposed to radiations at all, a change in their resistance to radiations would have no impact on their mutation rates. Thank you so much.